This video is going to discuss pH and pOH, which are discussed in chapter 18.3 of your textbook. This is going to be the main mathematical topic for this chapter, and it's going to involve logarithms. So if you haven't touched logarithms for a while, I would look back at your old math notes, see if you can refresh your mind about what a logarithm is. This is also a very abstract unit, so if you're not quite understanding the chemistry behind it, that's okay at this point. As long as you know how the formulas work, you should be okay at this point. So let's get started. I hope you understand how to do this math by the end of the video. So to start out with, let's review the autoionization of water. So if you have two water molecules in the liquid phase and they bump into each other, one water molecule has a slight chance of donating a hydrogen ion to the other water molecule, making hydronium and hydroxide. And in a typical sample of water at room temperature, if I multiply the hydronium concentration by the hydroxide concentration, I get 10 to the negative 14. And that's what's expressed in this formula here. Except I'm abbreviating H3O plus as just H plus. But if I'm multiplying the hydronium by the hydroxide, I get 10 to the negative 14. So in a pure sample of water, I have equal amounts of hydronium and hydroxide because each hydronium is produced when a water molecule collides with another water molecule. So I have equal amounts of hydronium and hydroxide in a pure sample of water. But let's say I add an ionic compound which donates H plus to the solution. So now I'm flooding my water with hydrogen ions. I have more H plus than OH minus. That's what we call an acidic solution. Now, when I increase the amount of H plus, when I increase the amount of hydronium, I decrease the amount of hydroxide. Because if a free H plus bumps into a free OH minus, they pair off and we get water. H plus OH minus makes water. It's like at a dance. If a bunch of single guys show up to the dance, the amount of single ladies decreases. Then if I take a sample of water and I add a lot of hydroxide ions, so now there are a lot of hydroxide ions floating around in solution, I have more hydroxide ions than H plus ions. And as my hydroxide ions increase, my H plus ions start to decrease because if I dump a lot of OH minus into solution, they're going to pair off with the H plus to make water. It's like if a bunch of single girls show up at a dance. They ferret out all the single guys from their hiding places in the corner where they're playing video games, and then all of a sudden you have couples dancing on the dance floor with guys that never would have brought a date to the dance otherwise. This equation says the hydrogen ion concentration times the hydroxide concentration is always 10 to the negative 14. So as my H plus concentration goes up, my OH minus concentration goes down. As my OH minus concentration goes up, my H plus concentration goes down. But as I multiply those two numbers together, I'm always going to get 10 to the negative 14. So let me ask you a question. What are the H plus and OH minus concentrations in pure water? Well, in pure water, I have equal amounts of H plus and OH minus because each H plus, which is really hydronium, is produced when a water molecule bumps into another water molecule. So this balanced equation here says I have one H plus for every one OH minus when two water molecules bump together. So if I take my formula here, H plus times OH minus is 10 to the negative 14, and I know that these two are both the same number, I end up with something saying x squared is equal to 10 to the negative 14. Well, if I take the square root of both sides, x is equal to 10 to the negative 7 molar. So the concentration of H plus and OH minus in a pure sample of water is 10 to the negative 7 molar. So, if you have equal amounts of H plus and OH minus, which you have in pure water, then your concentration of H plus is equal to 10 to the negative 7 molar. You increase your H plus concentration and you get more acidic. As you see here, as we go from 10 to the negative 5 molar to 10 to the negative 4 molar to 10 to the negative 3 molar to 10 to the negative 2 molar to 10 to the negative 1 molar, all the way up to 1 molar, we're increasing our H plus concentration. As we go from 0.01 molar to 0.001 molar to 0.01 molar to 0.1 molar to 1 molar. We're increasing our H plus concentration, and our solution's getting more acidic. As we decrease our H plus concentration, we go from 10 to the negative 7 molar to 10 to the negative 8 molar to 10 to the negative 9 molar, and so forth. We're getting more basic because we're adding more hydroxide ions that are taking away H plus from the solution. So there's a scale that we use to measure how much H plus is in a solution, and that's what we call the pH scale. pH is equal to the negative log of the H plus concentration. Remember, the log of something is just the power you raise 10 to get that number. So the negative log of 1 is 0. The negative log of 10 to the negative 1 is 1. The negative log of 10 to the negative 2 is 2. The negative log of 10 to the negative 3 is 3, and so forth. So the pH is just that number in the exponent. So if you have a 0.01 molar concentration of H plus, you have a pH of 2. You should have a pH of 2. So that means that the H plus concentration is just equal to the 10 to the negative pH. So if I know I have a solution with a pH of 3, I know my H plus concentration is 0.001 molar. I also have something called pOH. pOH is the negative log of the OH minus concentration. So that's the mirror image of the H plus concentration. So my OH minus concentration is just equal to 10 to the negative pOH. And this is the same deal as the pH, except we're measuring OH minus rather than H plus. All right, here's where things get really abstract and mathematical. I do not expect you to follow exactly why I'm doing the things I'm doing, but chemists like to talk in terms of pH, they like to talk in terms of pOH, and they also want to know the H plus concentration and the OH minus concentration. So what I'm going to show you is a way of converting between pH, pOH, H plus, and OH minus. Again, this is not going to tie to anything that you know physically, but hopefully it'll make sense on a mathematical level. So we know that the H plus concentration times the OH minus concentration is 10 to the negative 14. I'm just going to take the negative log of both sides just because I feel like it. So the negative log of H plus times OH minus is equal to the negative log of 10 to the negative 14. Well, then there's one of those log identities that you may remember from Algebra 2. The log of H plus times OH minus is just equal to the negative log of H plus the negative log of OH minus. And that all is equal to the negative log of 10 to the negative 14. Well, we know that the negative log of the H plus concentration is just the pH, and the negative log of the OH minus concentration is just the pOH, and then the negative log of 10 to the negative 14, well, is just the power you raise 10 to the negative 14 to, the power you raise 10 to get 10 to the negative 14, which is just 14. So that means that the pH plus the pOH is just equal to 14. So what I've done here is I've provided a convenient way to convert between H plus, pH, pOH, and OH minus concentrations. If I know the H plus concentration, I can just take the negative log of it to get the pH. If I know the pH, I can subtract it from 14 to get the pOH. If I know the pOH, I can just raise 10 to the power of the pOH to get the OH minus concentration. If I know the OH minus concentration, I can divide 10 to the negative 14 by the OH minus concentration to get the H plus concentration. So all four of these values are intimately related. And if I don't know one, I can figure out the other three. So I'm going to do a few practice problems of that, copy them down in your notes, and we'll do some more practice problems in class. So let's say I have 0.045 molar H+. So here's my H+ concentration. I'm going to find the pH first. So my pH is just the negative log of my H+ concentration, so that is 1.35. So now, once I have the pH, I can find the pOH, because I know the pH plus the pOH is just equal to 14. So the pOH is 14 minus 1.35, and that's 12.65. Now that I have the pOH, I can calculate my OH minus concentration, because my OH minus concentration is just 10 to the negative pOH, which is equal to 2.23 times 10 to the negative 14 molar. So now I have figured out my pH, my pOH, and my OH minus concentration just from figuring out my H+ concentration. Let's look at another example. So in this case, they want me to find the pOH, pH, and H+ concentration of a 0.045 molar OH minus solution. So first step, I'm going to find the pOH, which is just the negative log of the OH minus concentration, and that's 1.35. The pH is just 14 minus the pOH, which is 12.65, and then my H+ concentration is just 10 to the negative 12.65, which is 2.323 times 10 to the negative 14 molar. So if you notice here, I have the exact same numbers as on my last slide. The H+ and the OH minus concentrations are mirror images of each other. As one goes up, the other goes down. So you're seeing the exact same numbers if I have 0.045 molar OH minus as if I have 0.045 molar H+. They're mirror images of each other. Let's do one last example. Let's see if you can find the H+ concentration, the OH minus concentration, and the pOH of a solution with a pH of 3.45. If you use the flowchart correctly, you should end up with a pOH of 10.55, an H+ concentration of 10 to the negative 3.45, and an OH minus concentration of 10 to the negative 10.55, which is 2.8 times 10 to the negative 11 molar. So see if you got those numbers. We'll be doing more practice problems in class, and I hope to see you then.